Hi again. So this is video number 2. So this example is on the back of the first page of your handout. And this one's going to be how we can use that lowest common multiple, which is the same as the lowest common denominator, to solve a rational equation. Okay, so in doing this, we're actually going to end up turning this rational equation right here, the one that we have here, it's rational because we have a variable in the denominator. We're going to end up turning it into either a linear or a quadratic. We won't really know until we get our new equation after we're going to eliminate all of our fractions. So if you think back, we actually did this a long time ago with just numbers in the denominator. When we had a whole bunch of fractions in an equation, we looked for something that we could multiply everything by to get all the denominators to wipe out. So we're going to do the same exact thing here. So we're going to end up changing the format of this equation. So you're going to see our last step of this is that we have to check our solutions and make sure we don't get what we call extraneous values, which are kind of extra solutions. So the thing I like to do in the beginning is I like to look at all my denominators, and up in the corner I like to show what x is not allowed to be in this equation, just based on, think back when we were graphing the other day, when we were graphing rationals, there were values that x couldn't be because there'd be a vertical asymptote because we can't divide by 0. So if we pick out these values ahead of time, so in this case, x is just not allowed to be 0, then I know when I'm solving it, if I get a 0, then I have to say it's not a valid solution, and then I know that that's an extraneous solution. If I get anything but 0 in this case, then my solution is valid. So what I'm going to do is, the first thing I'm going to do is we're going to, if anything has to be factored, we'll do that. And I'll show you another example where we have to do that. But in this case, there's nothing that has to be factored. So we're going to find the LCM, which again is the same thing as the lowest common denominator. We're just not going to use it as a denominator. We're going to use it to multiply through the whole equation. So find the LCM of all the denominators. This is getting messy. If you thought my handwriting was bad and on the board, it's even worse on the video. Sorry about that. There we go. Okay. So that lowest common multiple of all my denominators would be x squared. Okay, so my LCM would be x squared. So what I'm going to do is I'm going to multiply through the entire equation by my LCM. Okay, and if I do that, if I do it correctly and I do it to everything, I should have no denominators left. So a lot of times I go over here and do my work on the side and show how everything cancels. So I have to do my LCM times 6, right? I have to distribute it to the 6. I also have to do my LCM to the 35 over x. And I'm not disregarding that minus. I'm going to put the minus back in when I see what I have left once I multiply through everything. And I have to do an x squared times my 36 over x squared. If I pick the right thing, I should have no denominators because everything will cross cancel. And I have to do the x squared times the 0. Now I know in this case that's going to stay 0, but if that were another number, I'd have to make sure I multiply it through as well. So when I do the first one, I get 6x squared. Nothing cancels out because there was no denominator there. When I do the second one, this x drops with one of those x's. And so I end up with a 35x there. Okay, the next one, I have x squared cross cancels with x squared, so I get 36. And then the last one, I have 0. All right, so I'm going to form this new equation. Let me just move this up a little bit. Okay, so my next step is I'm going to have a new equation that I'm going to solve. So sometimes I have to factor this depending on if it's a quadratic or if it's linear. So here's my new equation. I have 6x squared. Let me just check to make sure. And then that was minus, that's where I'm bringing down my minus, 35x plus 36 equals 0. So that's my new equation. So I turned my rational equation into a quadratic. Okay, so now I have to just solve that equation. However, if it's linear, I'll get everything on one, get all my x's on one side, my numbers on the other. But this one is a quadratic, so I have to solve. They will be factorable. You won't have to use the quadratic formula while you're doing this. In class, I picked this one because it was a good example to do AC method, just to kind of practice. I'm just going to factor it for you now, just to make sure the video is not super long. But I would go back and use AC method to actually get your factors. Okay, so you can check your factoring. So this is going to factor into 3x minus 4 times 2x minus 9. Okay, you can multiply that out and you'll get the quadratic above. And then, so this one, if I solve this one, I end up getting a 4/3 out of that. And this one ends up getting me a 9/2. So my last step, I have to check these. I have to make sure, I'm just going to squeeze in this step right here. I've got to check to make sure that these are valid answers. And the main thing I have to check for is what we said in the beginning. Now in the beginning, we said x is not allowed to be 0. Remember, we wrote that right in the beginning. So we're good as long as we didn't get that value. And since we got two different values, it is fair for me to circle these and say that these are both valid. Neither are extraneous. And we have to check them anytime we create a new type of equation. So let's try another one. So flip over to your next page. Let's try one more. Okay, so let's do the one, the first one there. So the first thing we have to do, if we're looking at this one right here, is we've got to decide what our least common multiple is going to be so that we can see what we have to multiply the whole equation by. So this one has a 1 denominator, so I don't really have to worry about trying to cross cancel with anything there because it just has a 1. This x squared minus 1, it's hard to tell what I need from that when it's not in factored form, so we're going to factor any of them. So that goes for like any of the ones that you see on this page. The first thing I would do is factor anything that can be factored, because then I know, then I can figure out what my LCM needs. So in this case, I need an x minus 1, and I need an x plus 1. I don't need two x minus 1s because each one just has 1, so just having one of those factors is enough. So let me rewrite my equation. I'm probably just going to take up this whole space with this one so I can spread out. Okay. And I'm going to go through the whole equation with my LCM of x minus 1, x plus 1. So this has to go to here, has to go to there, and has to go to there. So let's see if we can figure out what our new equation is. So you can go over, I don't have as much room here, but you can go over on your side and do all your work. Okay, so here, let me just show you what I mean. So I have to do x plus 1, x minus 1 to the 2 over x minus 1. So when I do that, these drop out, and I end up with, so my first equation, the first term in my new equation is going to be 2 times x plus 1. Okay, plus, now when I do my x plus 1, x minus 1 times the 1, nothing drops out. Okay, so that one is really just going to be x plus 1, x minus 1, which we'll come back and simplify it in a second. And then lastly, when I have to do my x plus 1, x minus 1 times my 4 over x, well, I'm just going to write it as that only because I ran out of room over there. But this would factor into those, so all of that drops, and I get a 4. So there's my new equation. I have no denominators, so now I'm just going to work on solving it. So I'd have a 2x plus 2. This is going to FOIL out into x squared minus 1. Okay, so let's clean it up a little bit and see. X squared, I'd have a plus 2x. Okay, so these two right here combine to a 1. And if I bring over that 4, it will be a minus 3 on that side. So it is a quadratic, so I do have to solve it by factoring. So when I do that, let's see, it should be x plus 3, x minus 1. Okay, so when I solve each one, I will get a negative 3 from that one, and I'll get a 1 from that one. So I'm going to pick out first, I'm going to go back up and say, I should have done this at the beginning. It kind of helps to have these values in your head. If you look at your fractions in the very beginning, we would say that x is not allowed to be 1, and x is not allowed to be negative 1. Because either one of those values is going to make one part of that fraction or equation undefined. So I did get a 1. Okay, so this one is not valid. So the only solution that I can accept and use is negative 3. So I would say the 1 is an extraneous solution and the negative 3 is a valid solution. Okay, so you have 2 other examples here that you can try and practice from, and we can look at the answers for those next class. And then you'll have one other video for the very back of this handout.